Hello students, this is design of machine elements 1. This video is a tutorial on chapter 2, which is static failure theories. So we will solve a couple of problems on how to use static failure theories that we have learned in class. So the first example here, we have given a bar which is subjected to axial load P and a twisting load T. This axial load creates a tensile stress of 180 megapascal, and this twisting load creates a stress of 100 megapascal. So, given these things, we are required to find out the factor of safety for the bar using MSS and DE or von Mises theory. So for that, we start with identifying the given data. So material is already selected. It is AI 1020 cold drawn steel. And the stresses induced in the bar are given due to tensile load. We have tensile stress of 100 megapascal. And due to twisting load, we have shear stress induced, which is equal to 100 megapascal. Now, for this load applied on the bar, uh, using this load applied on the bar, we are going to find our factor of safety using MSS and DE theories. This is the stress element on the surface of the bar, shown in plane stress form, sigma x, and this is tau xy, which is shear stress. So now, let us find out factor of safety using MSS theory, maximum shear stress theory. So as we have discussed in the lecture part of this course, maximum shear stress theory can be expressed in terms of principal stresses, or it can be expressed in terms of applied stress or induced stresses. So in this question, we have given applied stresses. So because we are given applied stresses, the suitable equation to use for this is equation number 2, which is maximum shear stress theory expressed in terms of induced stress. So since no information is provided about applied stress along the y direction, the value is automatically equal to 0. And another thing that we are given indirectly is the yield strength of the material. Well, the yield strength of the material can be read from a mechanical property table where we have already selected the material to be AI 1020 using this code. You can read for the yield strength and ultimate strength of the material. So yield strength is rated to be 390 megapascal and ultimate strength is rated to be 470 megapascal. Now we have all data here except the factor of safety, which is the one that we are looking for. If you substitute all values into equation number 2, you'll get such equation. Such value where all values are plugged in. So the only unknown thing here is factor of safety n. So calculating the value of n, you get the factor of safety to be 1.45. This is factor of safety found using maximum shear stress theory. Now let us find out factor of safety using distortion energy theory or von Mises theory. Again, von Mises theory is expressed in terms of principal stress like this, or it can be expressed in terms of applied stress like this. So again, the stress given here in the problem are all applied stress. We apply or we use equation number 2 for this case again. So equation number 2 will be the suitable equation for this. Now, substituting all the values given and solving for n will we get n to be 1.56. So this is factor of safety using von Mises theory or dissociation theory. So this is how you calculate for factor of safety using both theories. Now let's make a summary here. Always the factor of safety that you calculate using MSS theory is less than from the factor of safety that you calculate using the DE theory. That's why we always say MSS theory is more restrictive or more conservative than the DE theory. Don't forget, factor of safety that we have calculated using MSS is 1.45, which is less than from 1.56. So always, when you are solving on this in such kind of problem, at least this can be used as a check where factor of safety using MSS is less than from maximum, factor of safety using the DE theory. So this is how you solve this problem.